Okay, so the problem we're looking at today is encode and decode strings. This is continuing our content on arrays and hashing. And let's take a look. So it says design an algorithm to encode a list of strings to a single string. And then the encoded string is decoded back to the original list of strings. It's phrased a little strange, but we do have to write two functions, one to encode it in whatever way we choose, and then one to decode it in whatever way we choose. Okay, so yeah, please implement both encode, which takes the list, makes one single string, and then decode, which takes one single string and gives us back the original list. Okay, so the examples are not super interesting because, as you can see, whatever it starts as, it's supposed to end that way too. The trick is figuring out how we can encode it and then also reliably decode it, right? So again, these are identical, and that's on purpose. So we'll go over one very quick solution, and then we'll bring it back and do it kind of the intended way. So some constraints they give us, those strings.length. So the number of strings that we're given in that list will be between 0 and 100, so totally possible that there's no strings, and then there's up to 100. And then a particular string in that list, its length will be between 0 and 200. Okay, so we might have single, double, or triple digit string lengths here. And then a particular string in this list is going to contain only UTF-8 characters, so we don't have to worry about weird symbols or anything like that. Hello, welcome in. Yeah. So actually, I haven't done this one in a very long time. There is a method I'm thinking of that is good for under one certain circumstance, is what I'll say. Let's take a look though. So yeah, in terms of diagramming, there's not really much to say. I guess what we can talk about very briefly here is an issue that we might encounter with well, here's the trick behind the problem. Maybe you might attempt to implement it this way. If your list of strings is something, well, we'll use their example, like this. What you might think is, let me just use some kind of delimiter symbol to put these together, right? So we could produce one single string like neat, pound, code, pound, love, pound, U. And then we could just split this in terms of whatever delimiter symbol that we chose there. So that's one way we could do it. The problem with this is, what if the strings look like this? All of a sudden it's going to look like we've got neat and then a blank string or an empty string and then code and then love and then U. So there's a couple of things we have to consider here. One of them being simple delimiting is not going to work here. And that's because, in theory, any of symbol that we could use to delimit is going to also be a legal character for one of the actual strings. So that's one of the first concerns. Now, the hacky way to get around this is going to be to choose something that we know won't appear. And so what I mean by that is we could use like a literal illegal character or string of characters. Wow, am I allowed to write this? Is this gonna be too crass? Hi, Katie. I mean, hello, person who I know through Discord. Hello, welcome in. In case y'all are wondering, we are looking at encode and decode strings. This is day 6 of the Blind 75. Okay, so one way that we can handle this encoding to a single string is to use something that we know is illegal. And here's what I mean by that is we could say, oh, you know what, actually, let me check one thing real quick. We could say something like, let's join these with, I'm gonna censor myself here. I'm gonna say, oh, surely this is not a delimiter that would ever appear in the actual answer. And we could just return that. So this is gonna produce the original string with some illegal character in the middle, or a string of characters for that matter. And it's actually a little bit more complex than this because we've got to deal with empty strings as well. And then to decode it, all we need to do is split it based on that illegal character delimiting. So we can use the split function here, this string, and we would return that. Now this kind of works and it kind of doesn't. We'll actually run it and talk about why in just a sec here. Oh, hello. Oh, you know what? I actually have got the syntax backwards here. This is supposed to be string.join, I think. Yeah. And then the array goes here, and then the split is actually backwards. This is going to be strings.split. That. Okay, so now let's run it and see what happens. This is just S. I don't know why I've done that. Okay, there we go. Okay, and you can see it actually works for these couple of cases. It correctly encodes it to something that is delimited with characters we would never see in the actual input. And then it decodes it using that, again, that illegal character. Now, here's one problem with using this exact method is when we submit, you'll notice that some weirdness happens when we got empty strings. Basically, the reason for this is that when we well, let me think about this. Let me actually print this so that we can get some analysis on it. We'll print this. And then we'll also print... Oh, actually, well, we're going to return that, so we're good. Let me go ahead and resubmit this. And we'll take a look at the issue. So, oh, actually, no, this is interesting. What I was expecting to get here was one single one of those delimiter characters, and we didn't get that. Let's see if I remember what the issue is exactly here. I believe what we want to do is split this in such a way that we have something in front telling us, by the way, the string has started. Let me think about this. We need something in front telling us that the joining has started, I believe. And then, ooh, is this gonna really be the first one that I get stuck on? This is embarrassing, because this isn't even the best way to solve it. Okay, I'm gonna breathe for just a moment here, because I definitely can solve this. We join this together here, and it produces, the input is the empty. Oh, you know what? Actually, I think here's step one. If we... I believe if there's no strings, and this is, you can tell that this is real hacky. This is why this is our first solution here. But if there's nothing in strings, we can just return the empty list, I believe. And I think this forces us to run into a second test case that immediately goes, yeah, you can't do it that way either. Now what I wish we could see here is, because when we printed this, what we got was just nothing. And this is because, what, it's an empty string? Okay, and then what we ended up returning is a list with the empty string in it, which is not what we want. Okay, so I need to figure out this mapping. I think what we want is to have some way of indicating at the beginning, let's see. So if there's nothing in the list, we'll return, the empty string. Okay, and if that's the case, then when we get to decode, if we have the empty string, we know we can return the empty list. Okay, so this is saying when we encode it, if it's the empty list, return an empty string. When we decode it, if it's an empty string, so if not S, then we'll return the empty list. We need then some other indication of whether or not the end. Okay, actually, I'll submit it, and then it'll tell us the other test case that goes, sorry, that's not enough. That's actually not sufficient to solve the problem. And you'll see when I submit it this time, the test case that we fail is the empty string, because right now we have no way of distinguishing those two types of inputs, right? So what we can do is we can say, actually, let's go ahead and say if there was anything in the original list at all, we'll put something in front. In this case, I'm going to use that same illegal delimiter here. So maybe we'll do like something like this. And again, you can tell that this is super hacky. We're going to get a much more elegant way of solving this in just a sec. And in fact, I don't even need to put that in a variable there. We can say this plus that. And so what this is telling us is, assuming that there was something in the list at all, we'll put this symbol at the front to indicate. We are going to post days 1 through 5 hopefully soon. We have recordings of various qualities for them. With that said, if you go to the problem threads in B75 daily problems, there's actually tons of solutions in there as well. I'm not 100% sure where we're going to post the missing days yet, but we're going to get to it, I promise, soon. Yeah, Ivy's probably got a better, more planned out answer for you on that. Also, our GBM today is going to cover a lot of the content that we've been talking about for days 1 through 5. So if you come back at 7, we'll have some good stuff for you as well. Okay, so when we get to this return statement, we're saying, hey, if we got here, this means there was actually something inside. We have some way of indicating that now. And what we can do is when we split this, we can return not the first thing, because that will be just a throwaway symbol. And we want everything from index 1 or to the end. Okay, so I think this completely solves the problem. I guess we're going to find out because I'm about to submit it again. Canonically concatenate list. Oh, I forgot it's a string. Okay, my bad. I tried to do a list plus a string here. This is just supposed to be a string plus that. Okay, and then this time we're going to split it and throw away. Ooh, actually, we might be throwing away the first two. I'm not 100% sure how it splits this. So let's see if this worked out the right way. Okay, great, and it does. So essentially what this does is it lets us distinguish between an empty string and a completely empty list, which are distinct things. This way we catch up here with these if statements, whether or not we started with an empty string, or sorry, if we started with an empty list, and then assuming the two different things that we're distinguishing here are this versus this. One of them is a completely empty list with nothing in it, and the other one is a list with the empty string in it, which are distinct in this case. Because again, we need to return the original list. So the if statements here catch this condition. If it was a completely empty list to begin with, then we send the empty string. And then the extra thing we're doing here, where we append an extra delimiter, is going to tell us, hey, there was something in here. What exactly was it? Well, we can figure that out by splitting it here and throwing away the first part, because the first part is just the start of the string. It's like, hey, this is me indicating that there was something in the list. The rest of it is the actual string that we are working with. Okay, so that's one way to do it. Again, this is sort of hacky. It's not intentional. If you do happen to, and actually this is sort of something that companies will do, because there are ASCII characters that are non-printable, so they're never something you could submit as a user, right? But you can use them for delimiting as a programmer. So that is actually something you can do here, and it obviously simplifies the problem greatly, but we would like, if there's some way that we could do this without needing to resort to such crass programming as this. So let's talk about it. What we need is some way to encode these strings where the strings themselves cannot interfere with our encoding system. There's a lot of stuff we could talk about as far as like getting us there, but I'm going to launch us straight into the solution here so we can end on time. Here's one way we can do it, and I'm sure that there are other ways, but this is the way that I learned. That's the one I'm going to teach you guys. Is we can have a system where we start. Well, first of all, let's begin with this. We actually have to start with whatever our system is for decoding. And what I mean by this is each chunk is going to have, hey, here's info about how to get the next string, and here is the actual next string. Here's info about how to get the next string, and then here's the actual next string, right? So everything is going to follow kind of this pattern here. We have to start with whatever our system is for encoding, because otherwise the string could be anything, right? We have no idea. Maybe it looks identical to our encoding system, right? But here's the catch: is as long as we can start with the encoding system, we know we'll have some way of reading it and knowing where that encoded information stops. And then even if we encounter it in the future, we won't have to worry about it because we know that that section is not for the encoding. Is this kind of giving Oshawott? Anyways. Okay. So that's what we need to do. And here's a system that we could propose for it. I want to just remind you guys of the parameters, which is that the strings themselves can be anywhere from like 1 to 200 characters or something like that. So they could be 1, 2, or 3 digits. We could do something like this. We could say £4 the next string. Okay, and what this says is there's 4 letters in the next string. The pound separates the numbers from the string itself, and then you get those characters, and then the next one will be £4 code, and then £4 love, and then £3 you. And since we're starting with that encoding system, we're guaranteed that the first pound sign that we hit is going to be, hello, welcome in. We're guaranteed that that first pound sign that we hit is going to be part of the encoding system and not part of one of the strings. Now that we have that information, we can go across to where we need to go. And as soon as we're done with that number of characters, we know that we're hitting another encoding system. We do the same thing, and eventually we get to the end of the string. Okay, so that's the system we're going to follow. It's a little bit like it's going to be a little bit of a pain in the butt to code because we got to deal with like how the indexes work together. But let's see if we can do it together. So again, one solution that works if we know that there's certain delimiting characters that are never going to appear in the original strings. But here's how we can do it this way. We can say, wow, actually, I didn't really think about how to actually code this part. So let's think about it for a sec. It's definitely, when we're done, going to be just one long string, right? Now, one note about performance here. In Python, and actually many programming languages, strings are immutable, meaning that if you constantly build new strings or put strings together or whatever else, it's very slow. It's very expensive to do that. So generally, if you need to build a very long string, the recommendation is to use a different data structure like a list and then just join the entire list together. So we'll probably do something like that. But how are we going to do it exactly here? I'll say well, first of all, let's say encoded string maybe is what we'll call this. And I'm going to actually make it a list, which is a little bit, maybe I'll say encoded string list. And I'll say for each word, and again, I'm not going to say str here because that's a Python keyword. I'll say for word in strings. We'll start by adding the length of the next string and also the pound sign. It doesn't really matter what this is. It just needs to be something that you can catch, which basically just means it has to not be a number. You could make it a letter. You could make it whatever you want, because this always is just going to come after the numbers, and it tells us, okay, we've now read the length of the string. And again, the reason we need some kind of symbol like that is because the length of that number could be 1 digit, could be 2 digits, could be 3 digits, and then the following string could start with numbers, right? So we have to guard against that situation. Anyway, so we add on this encoding information, and then we add on just the word itself. Okay. We'll go ahead and print encoded string list just so we can see it, and then we'll talk about where to go from there. I'm just going to have this do that because I don't want it to give me or to complain too much. And I'm going to have this return the empty string. Okay, let's run it. Oh, what did I do? Okay. So this gave us a number. The next part gave us a string. It went, hey, I can't add together a number and a string, so I'm going to go ahead and cast this as a string, just so it puts them together. Okay, so let's see what we've got. We got 4 pound neat, 4 pound code, 4 pound love, 3 pound you. Is this the same? Okay, yeah. Oh, now actually this is interesting. Okay, no, yeah, that's a colon. I thought that was part of a map. Okay, so we got 2 pound we, 3 pound say, 1 pound colon, 3 pound yes. I wish there was an empty string in this, and actually I think we can like construct our own test case. Hello? Oh. Hello? Is that not something I can do? Okay, at some point you were able to do that. I don't know what's going on here. Hello? I feel like I'm supposed to be able to modify this. Well, anyways, we'll see it when we submit it. If there's an empty string, we're still going to get information about it. It'll just be 0 pound, and then there's nothing there immediately. Another encoding starts, which is totally fine because the 0 tells us that there's nothing in that string anyways. So I wanted to show it, but I don't know what's going on with the test cases here. Okay, so what we need to return, though, is not that list. We need to return, I'm going to say empty string.join encoded string list. And again, this saves us from having to like constantly build a new string, which is comparatively computationally expensive. Okay, so now we've got something that looks like the thing I was just talking about. In fact, I'll split view this just so we can see both of them at the same time. We have something that looks like that string right there. And now we've got to tear it back down to the original list. Okay, so how can we do this? I'm going to say, ooh, we could use... Okay, so I'm going to say for... well, no, it's not going to be... So we can't really use a range-based for loop here, and that's because kind of the pointers that we're working with jump by kind of arbitrary or unexpected or, you know, by increments that we can't plan for. So instead, I'll just say we need like a left and a right pointer, and really these are just indexes that we're dealing with at any particular time. So I'll say I and j are 0 and 0, and I'll say while I is less than the length of s. Okay, so basically what we need is 2 pointers that will... Ooh, I wish I could access the colors here. Yes, we need 2 pointers that we can use to read the sections of these strings. So for example, we can read these, and this gives us the information about the encoding, and then we can swap the red pointer over here and the orange pointer over as far as we need it to go, and that'll let us capture a section of the string, and then for the next section we'll do it again. So, oh, what the heck is that? Okay, so that's going to be our I and our j here. We could call them left and right. That might be more informative. In fact, I'll call it that. Okay, so while the left pointer is still within the range of the encoded string, what can we do? We can say j equal, well, there's a lot of ways we can do this. I'm going to say, for starters, j equals I, just so that we line them up. And then, ooh, we can say, well, j does not equal the pound sign. Move j to the right by 1. Okay, so this is equivalent to us having both of these, well, the red starts here, the orange starts in the same place, and we say, hey, as long as the orange is not pointing at a pound sign, which means it's pointing at a number, go ahead and keep moving it to the right. But once it gets to the pound sign, we know that we've read out, or we're aware of what the length of the next string is. Okay, And so we can say now, I'll say string len equals, okay, we talked about slicing before. I'm going to say s from I to j. And again, what this means is include I and then keep including everything up till j and don't include j itself. So in this case, we just get 4. The pound sign is not included, which is what we want, right? Okay. Now this is going to get us a string, but we actually want the number form of it, so I'm going to go ahead and cast it as an int, and we know that it's going to be an int because that's how we encoded it, right? Okay, and then now that we've got the length, we can say I equals j plus 1. So we know that j is currently at the end, or it's currently at the pound sign that comes right before the actual next string. And then j is going to be I plus the length of the string that we're looking at. Okay, what this is actually going to do, okay. Oh, I and j, sorry, I forgot I renamed them left and right. Let's rename these, sorry, right, left, right. Oh no, and it's supposed to be s right. I'm so glad actually we talked about this. Man, I just got in the zone. Okay, let me rename all of these. Okay, so remember, left and right are the indexes here, right? Okay. Can I move that over more? No, okay, that's as far as I can move it. Okay, so left and right both start at 0. All they're tracing is indexes of important parts of the string. This first section, in fact, I should actually comment this better. Read the encoding formula. Right, that's what this section is for. And then when we get here, this is read the next string. Okay. Okay, so we start by saying, let's put them at the same place, and then let's have the right pointer move over until it hits a pound sign. That's how we know we've gotten to the end of the encoding formula, right? Okay, once we get there, go ahead and read the stuff between, oh, and I didn't change this either. Go ahead and read the stuff between left and right, and that's how long the next string is. Okay, and now we know how long the next string is. Go ahead and read the next string. So since we know that right at this point is at the pound sign, we can move left just to the right of it, and then we can move right however far over the length of the string is. Okay, so left equals right plus 1. That's going to take this over here. Right equals left plus string length. That's going to take orange over here to the 4. Okay, and you might go, well, hold on, that's not where the next string, that's not where this string ends, and that's correct, but remember, the way that we slice strings, the last index is exclusive, so we actually want it to be one past the end. Okay, so I just realized we actually don't have a results list yet, but we need that. So now that we've got this, we can say, go ahead and add on the section of the string that we're looking at, which goes from left to right. Okay, let me do this. Hopefully that's clear enough. Okay. I think that's it. So this is just going to go through, again, we've got this outer condition that says, hey, as long as we're looking at an index that actually makes sense for the string, read the encoding formula, which is number pound sign, and then read off the next string, which starts right after the pound sign and goes till whatever the string length that we just found was. Okay. Does that make more sense, Ivy / anybody who might have questions here? Okay. Yes, we do need to return. Girl, the return. So what are we going to return now? Res. I think should do it. Let's see if I did that correctly. Oh no. Now what have I done? Oh, hold on. By the time we get here, so after we actually get that string, I actually has to be, or not I, sorry, left has to be right plus 1. Because we know by this point, So actually, let me make some comments. Right is at the end, or at the, oh no, actually left is just going to be equal to right. Right is at the start of the next encoding formula. And similarly, up here, the reason that we can do this is because right is at the pound sign, which is right before the next string. Okay, let's run it now. Okay, great. And that does the thing that we wanted to do, and hopefully this does the thing we wanted to do too. Great. And that's that. Took a little bit longer than I was hoping, but it worked out. So, great. Any more questions, comments, ways that we could have, oh, you know what, actually. This fun fact or thing to be aware of, if you're ever on this happens to me all the time, if you're ever on LeetCode and you're like, wow, I actually thought I coded that well and it's performant, but it's like the bottom 10%, you might have print statements, and those really slow things down. Not that that changes the functionality here, but you know, now you know. Okay, questions, comments, concerns, song recommendations? Oh. Yeah, well, I mean, decode doesn't care unless it's egregiously slow, so if it's like especially bad, sometimes it'll limit you to basically tell you like choose a better approach or a more efficient approach. So neatcode doesn't care, but leetcode, it very much does slow it down. Especially if you've got lots of print statements, it's going to slow it down quite a bit. Great. Well, thanks for tuning in, guys. Yeah, again, the recordings for the first like week or so will be posted at some point. Oh, an actual song rec. We love that. So those recordings will be posted at some point, and then we will be hopping into our general body meeting at 7, also on Discord, where we'll talk about a lot of the content that we've covered in those first few days. So it could be helpful if you got the time to stick around, but I'll see hopefully some of y'all there. Bye, guys.